All right, we're going to do an algorithm that will show if the characters inside each node of a linked list form a palindrome. So say we have M, A, D, A, and M. Then we're going to want to figure out if we are having a palindrome. So a clarifying question would be, do we care about case? Are we case sensitive? I'm going to go ahead and say that we are case sensitive. So capital M does not equal lowercase m. All right, so to do this, I think we'll just utilize a stack. And if we put, as we traverse the list, and we can go ahead and just push everything to the stack. And once we hit the end of the list, we can go back to the beginning. And then as we pop up, each element is M equal to M. Yes, let's keep going. Is A equal to A? Yes, let's keep going. D and D, yes, let's keep going. Pop up this A, is it equal to A? Yes, it is. And pop up this M, is it equal to M? Yes, it is, and we're done. And we can just set a Boolean, and if at any time it's not equal, we can just kick ourselves out of the loop and return false. Okay, so let's go ahead and write this up. Let's go ahead and make a node class. It's going to have, the data is going to be a char, and then it'll have the next node, and its constructor is going to take in the data and let's say D. So data equals D, next equals gnome. Okay, so there's our class. And if we wanted to make a quick linked list class, then we've got, it just takes a node head. Okay, so let's go ahead and write this function. It's going to return a Boolean. Is it palindrome? And let me make this capital as palindrome, and it's going to take in the head. Okay, and we'll want to set up a Boolean. We'll start it at true. We'll just assume it's going to be a palindrome. We also need some sort of pointer to walk through our list. And we're going to make a stack. We'll call it pstack for palindrome stack. Oops, and that is a stack of chars. Okay, and then what we'll do is first we'll loop through. Oops. Yeah, okay. So first we'll loop through and we'll say while PTR does not equal null. Then we want to pstack dot push, and we're going to push ptr dot data, and then we can say ptr equals ptr dot next. Okay, and then once that gets all the way to the end, we will want to reset our pointer. So PTR equals head again. And then while PTR does not equal null and we have a palindrome still, then we can go if stack.pop does not equal PTR, then is palindrome equals false. Otherwise, we're going to say PTR equals PTR dot next and walk through that. Okay, so then at the end, we're just going to return is palindrome and end our function. So let's walk through this and see if it works the way we think it's going to work. So let's try a new linked list. Maybe it's got C, B, D, D, B, and C. So we're expecting this to return true. Okay, so here's our pointer. Let's draw a stack. Here's P stack. Okay, so well, pointer does not equal null, which it does not. pstack.push ptr data, so that would be C. PTR equals PTR not next. So now our pointer is here. And then pointer does not equal null, so stack.push the data, so B. Then pointer equals pointer dot next. Still not null, so stack push D. And we advance here. Still not null, so we push the D, advance our pointer. And stack our data still not null, so B, push our pointer. That's still not null, so we push C. And there's our pointer. Now it's null, so we get out of that while loop. PTR equals head. Well, PTR does not equal null and is a palindrome. So as palindrome is currently true, we go in stack.pop, so we get C. And we're saying is C, if C is not equal to C, and there we need to say pointer dot data. If it's not equal to C, that is false. So we go in and we say PTR equals PTR dot next. And we go in, we're not null, and we're still palindrome. So we go in stack.pop. So we pop this B. And if it's not equal to pointer's data, which it is, so we get out of that, or oops. So we go back here and we go to PTR, and it's still not null, and we're still a palindrome. So stack.pop D. We're looking at this D. If D is not equal to D, which is false, so PTR goes here, and we are still not null, and we still have a palindrome, or is palindrome still true? So we go in and we say pop this D if the D is not equal to D, which is a false statement. So we go in and we say PTR equals ptr.next. And ptr is still not equal to null, and we're still isPalindrome, so pop this b, and b is equal to b, so our if statement is false. So we go in, we get to our c for ptr, and ptr is still not equal to null, and isPalindrome is still true, so we pop this c, and we take c as c equal to c, and they are, so our statement is still false. So ptr equals ptr.next. Okay, and then now ptr is null. So we get out of that and we return isPalindrome, which is true. All right. So this algorithm takes O of n times, although that's worst case. Hopefully we will discover it's not a palindrome earlier on in the looping. So really it's O of 2n because we go through twice, but hopefully it's a little less than that 2n. And then the space is O of n because we're using the additional stack.